moving slightly on from astrophysics onto astro-ecology.
Yep.
So how did that come about? Because is that a kind of a relatively new area?
Yeah, so probably about 5 years ago now. So I've always been interested in sort of interdisciplinary stuff, but so I guess when you're talking about probabilities and random chance, so my next door neighbour turns out is an ecologist.
Ah, okay.
And so he is, he's a world expert on primates and orangutan, and so he's I'd say an observational ecologist in the sense of he collects ecology data and tries to use that to
in the field. He actually goes out.
I mean, he spent his PhD in the middle of jungles for like literally 6 months counting around.
Some people
so
are
he's
cool,
hardcore. I mean, he's got some great stories.
I spent 3 years behind a desk in Liverpool.
Yeah, man, I suck, man. I fucking suck.
Yeah, exactly. Yeah.
But yeah, so you met
one of those things, and you think I've made wrong career choices. At some point, right?
So this neighbour then is an ecologist.
Yep. So Sergevic is my next neighbour. So he's this ecologist, and so he was starting to use drones so instead of sort of going through the jungle and manually counting orangutan nests, which is I think the sort of his thesis work, starting to use drones. So drones are coming in; they were big, and so the question is, yes, right, we can now fly drones, we can get loads of data, but how do we make sense of that data? And in particular, how do you find animals? Because animals have, kind of keep going back to the same things, have spent billions of years evolving not to be seen, right? Yeah. They want to be camouflaged, they don't want to be eaten by other things. And so it turned out that they were starting to use thermal drones, so drones with thermal infrared cameras that can detect the heat radiation, and the animals, so you're familiar with these thermal cameras that like the police shows where there's a robber hiding in the bushes
and he just sees
and he's just like, come on man,
see him with the buck.
Exactly. Haven't you watched the telly? Don't you know? We can see it. So you find the guys in the bush. So the same thing. So finding a robber in the bush is the same thing as finding an orangutan in a tree, right? But and astronomers have been using thermal cameras for, we were some of the first people that developed them to study things like stars and planets in space. So we're used to really extracting every last bit of information out of images, and so we started working on I was trying to help basically do astronomy but pointing down, so doing astronomy
just reversing the telescope,
instead of pointing up, pointing down, and finding animals in the ecology footage was how it started.
Just build on from there. So you started the field of astro-ecology?
Well, I'm
bold statement, but I'm throwing it out there.
I mean, I don't. Yeah, I feel a bit. So I don't even know if it is a field, to be honest. I mean, it's what we called our. So when we started applying for grants, so this was like Serge and I, and we're like, let's try this. Let's see if we can get this to work in it. And we applied Astro techniques, and it worked. I was like, hey, this is cool. Should we write a grant? So we should actually try and take it to the field and go and count orangutan or whatever. Like, yeah, cool. Well, we've got to come up with a name for it.
The name's badass, like.
The name's so cool.
Well, I was going to say, my astro colleagues hate it. Because
do they want to call it?
Well, it sounds like ecology on other planets.
Like, I see what I mean? Yeah.
Like ecology on extrasolar planets. So to them it doesn't. So in my way of thinking it's combining astronomy on ecology on Earth, but there's
it's the techniques you combine,
exactly,
and not the way you're looking.
So I mean, so you could have the other way around. You have ecology astrophysics or something where you're doing ecology on other planets. So anyway, we chose that name and it just kind of stuck. So we are now, our little group is our Astro-Ecology group.
I love it.
So what are some of the things then that your group's been involved in?
Okay, so
what he's focusing on, what animals he's focusing on, what's the...
So we're actually working with, so we expanded the core group, so it's Serge and I, and now we work with two computer scientists actually. So Paul Fergus and Carl Chalmers, who are black belts computer vision folks, and we take basically any data, and as I was saying, the core thing we do is we find and identify any, if you want an animal, we'll train a model to find it. So it's all about getting the data, doing the tagging, and running the predictions on that. So that's the kind of the core. So we're doing.
So you're working with ecology groups then, who are wanting to look after certain animals.
Exactly. So they will come to us and they'll say, look, we've got 100 hours of footage. We've flown over the forest for 100 hours, And what typically would happen was that there'd be a PhD student whose job would be to sit there and have 10 cups of coffee and try and say and count animals and no, before even tagging.
Just count what's
by
there.
eye. So it was by eye, and then it was people were trying to develop their own machine learning models, which is all well and good, but we've developed something which we call conservation AI. So Paul and Carl's is there, the sort of where they've taken really the cutting edge machine learning in computer vision, and so anyone can upload their data, and you say, right, here's my data, you put it in the pipeline, and it'll say, right, there's this animal here at this location, and the idea is that it speeds up going from taking data to doing actionable things like, right, we need to put a fence here, or this is where the poachers are getting in, that kind of thing. The ecologists need to know that as soon as possible to deal with the problem.
Yeah.
And so we're basically fast-tracked that.
Fast-track the manual looking through.
Exactly. And so now, the system, we've got camera traps in different projects, and we can, there've been some project we're working on where they're interested in poachers. And so, for example, in pangolins in Uganda, so pangolins are these, I don't know if you've seen them. There's these. Have a look on the web for what pangolins are. They're kind of like pangolin, yeah.
Oh yeah, I only know about pangolins because
I'm gonna have a look.
Have you seen the South Park special about COVID?
No.
Have you seen it? No. Well, apparently COVID started because Randy in South Park had sex with a pangolin. That's the only reason I know what a pangolin is.
One of those.
They're pretty odd looking things, but they're
kind of like
really
armadillos.
They're kind of like armadillos, but yeah, they're super. And they get poached.
What do they get poached for? This is very off piece, but
it's very off piece. They get taken to basically China, where they're
food market or medicine market.
Yeah, and there's a huge price for these things. I think I'm not sure. So but yes, we basically have the system that a human appears in the camera footage where there shouldn't be. And it's immediately inferenced. It's a text message or an email sent within 2 seconds.
Like real time tracking.
In real time, 2 seconds from detection to the ranger, who can then make an intervention if that human's not supposed to.
So is this from? This is not from drones then. This is from.
That's camera traps. So
we're camera traps. So
the algorithms don't care. It doesn't matter where the data come from.
Yeah.
It's agnostic. So it works with camera trap data, it can work with audio data if you train the model correctly. But it's training the model for the environment and the species.
What I really like most about this is the fact that it's actually a deployed piece of
it's out
development.
There. Yeah, we're working with Chester Zoo, working with Knowsley Safari.
Because it's great because a lot of machine learning stuff tends to stay in especially in healthcare, it tends to stay in the realm of, we've done a thing, we published it, this could work, but it's
the transition, exactly. It's the transition out there, and I think that's what Paul and Carl have been so successful in. It's this end-to-end application of...
Real-time application where you can see
exactly.
what we're doing.
And it's operating in the field in tens of countries and all different continents, and so I think that's... I really hope that it's going to have a sort of long-term impact in these general areas.
So is there a website that people can go to?
Yeah, Conservation AI.
ConservationAI.com?
I think if you just Google Conservation AI.
We'll put a link to it in the description. So if you have any footage, upload it, help the guys out, help yourself.
Absolutely.
We'll see what happens.
Did you guys... I was... Sorry, this might be even more off topic. You mentioned Chester Zoo. I was at Chester Zoo, and in the elephant bit, there was this PhD student who had used cameras on the elephant compound. Is that you guys?
I have no idea.
No, sorry.
There's
loads.
There's lots of different researchers doing that. So I don't want to say yes and it's not.
No.
we do lots of things, and there's lots of different projects and PhD student.
Is there loads of... I was just thinking about the applications of sort of astro-ecology, if you like. Then outside of, I suppose, animals, you could use it for track a natural disaster like a wildfire or...
we do fires.
You do fires. You do
thermals. So we were in... so it turns out that...
And basically with a signature.
Yeah. Well, so we work with people all around the world to... So fires are a major problem for deforestation. Also for peat fires in particular are a major source of carbon being released to the atmosphere.
Yeah.
Peat is an amazing sink of carbon, and so Indonesia, for example, there are some years where the peat fires release more carbon than the whole of the world transport together.
Yeah.
Wow.
Just one peat fire, then
It's all
everything,
released.
planes, cars, the whole lot, the peat fire outdoes it.
Just because it's such a good
carbon store. And the problem is that it burns underground. So it's not like these flaming forest fires, because peat, as you know, sort of is in the ground. So you see all the smoke, but where the hell's the actual fire? And it takes something like 100 litres of water to put out 1 square metre of peat fire.
Shit.
So, yeah. And then it's in the middle of nowhere, and you're far from a river, so if you're going to, you better point your hose in the right direction, so to speak, right? So yeah, we've worked with people in different places to use thermal drones to pinpoint exactly where the hot, and it can see through smoke because it's the thermal.
Yeah, of course. It
sees through the smoke. Boom, pinpoint it, put out the fire, and yeah, so it's another kind of application.
And catch them, I suppose.
You got to catch them early, because by the time they get big, you forget it. I mean, if you think 100 litres of water for 1 square metre,
for a square
one
metre?
metre squared,
100 litres for a square metre.
Yeah, it's ridiculous. Yeah,
That's
once it's properly
insane.
burning.
That doesn't even make any
deep.
sense if you look at it.
I know.
100 litres of water
100
for this metre.
is insane. But it's because the peat can be several metres thick, and it's all burning. So you imagine you're just trying to put out your backyard.
Shit, man.
You know, if you have your bonfire
Yeah,
that's coming
yeah.
up soon, right? Bonfire,
Yeah,
right?
yeah.
Imagine how much water it takes to put that out when it's when it's absolutely raging, and then you've got.
But that's several metres on the
That's
ground.
several
as well.
metres, and it's
Wow.
also. Yeah,
Is there any applications then, Stephen, where you're looking to use Astro-Ecology? Where you're thinking that could be definitely useful? We just haven't got the tools or the protocols in place to make moves in that
lots of areas.
field.
I mean, I think it's such a general. The thing that we're developing is such a general problem. It's like finding and identifying things, right? And
Yeah.
you can think, you sit down, you have a beer, you come up with 5 ideas, and we'd love to explore all of them, but we're just, it's just time and
Yeah.
Time, money, and manpower, basically.
That's it. You've hit it, yeah.
Yeah.